Shri Gurubhyo Namaha, children. Welcome to our online teaching academy, Ekalaiva. Today we are moving on to the fourth chapter in physics, electricity. Now you would have learnt about this electricity in your lower classes, but here we are going to go in detail much about this electricity. Now, electricity is an important source of energy in modern times. Now, you cannot imagine anything without electricity nowadays. We use electricity everywhere, in our homes, in industry, and in transport, everywhere. Okay. Now, we use electricity in our homes for lighting. Okay, lighting. Then for operating fans and other heating purposes, we use electricity. Now, in industrial field, it is used to run various types of machines. And in transport sector, electricity is used to pull electric trains. So many other transport machineries are run with electricity, right? So, nothing is possible without electricity nowadays. That is the scenario of today. So, in this chapter, we are going to talk about the electrical energy, and we are going to get introduced ourselves with some new terms regarding electricity, like electric potential, then what is electric current, then what is electric power, and we are also going to learn about the heating effect of electric current. But before we go on understanding these terms, we should set ourselves to know about what are electric charges. Now, these are some of the uses of electricity in our daily lives, like electric motor, electrical appliances, electric generator, electric bulb, LED bulbs. So, all these things run with electricity. And for your online classes, maybe you are sitting with your laptop, your mobile phone, everything. To charge a mobile, you need current. So, without current, nothing is possible nowadays, right? So, with this we are moving on to what are called as electric charges. Okay. Now, to understand electric charges, let us take an example of a plastic comb. Now, you have a plastic comb in your home. So, bring that plastic comb. When you bring it near tiny pieces of paper. Now, I have shown it in the diagram. Now, when you bring initially the comb near some tiny pieces of paper, it will not have any effect on them. Definitely, you will not have any effect. But what do is, you rub the comb. Okay, the comb is first rubbed with your dry hair and then bring it near the tiny pieces of paper. Now, this time, what will happen? We can find that the comb will attract pieces of paper towards. So, what is the reason for this? Initially, when you bring the comb without rubbing in your hair, there is no reaction with the papers. But after you rub the comb with your hair, now when you bring it near tiny pieces of paper, the comb starts attracting the papers. So, we can say that initially the comb was electrically neutral. Now, electrically neutral in the sense it was not having any charges, right? So, that is why it does not had any effect with the papers. But when you rub, when the comb is rubbed with dry hair, it gets what is called as electric charge. Now, we are charging the comb by rubbing it with our hair. So, it gets electric charge. Now, when the comb is electrically charged, definitely it will exert a force on the tiny pieces of paper. So, due to the force, the papers are getting attracted to the comb. So, initially the comb was electrically neutral and there is no force. But after it is rubbed, the comb becomes charged. Okay. Now, similarly, we can give other examples like take a glass rod. When you take a glass rod and you rub the glass rod with a silk cloth, okay, or an ebonite rod rubbed with woolen cloth. Now, also acquire. Now, it will also be able to attract small pieces of paper, and they are said to possess what is called as electric charges. Okay. Now we are going to go in detail about the properties of electric charges. So what are the charges? What are the mainly the charges are of two types. One is you call it as a positive charge. The other one you call it as a negative charge. Okay. Now what are the properties? To start with, the first property of an electric charge is opposite charges. Opposite charges in the sense you have a plus charge and positive charge and negative charge. Opposite charges. Okay, or you can also say it as unlike charges. Okay, so opposite charges or unlike charges attract each other. A positive charge attracts a negative charge. Okay, similarly, like charges, similar charges in the sense positive. Okay, two charges or negative, similar charges, they repel each other. These are all very important properties as far as electric charges are concerned. Like charges repel each other, unlike charges attract each other. Very important. Now that is why when you rub a glass rod with a silk cloth, initially the glass rod and silk cloth, they have neutral charges, but when you rub it, now you are doing the process of charging. Yes or no? So in the process of charging, now the glass rod acquires positive charge and the silk cloth acquires negative charge. Okay, so charges are, initially the charges are neutral, but after you charge, the charges are not neutral. They acquire either positive charge or negative charge. So when opposite charges are there, it will attract each other, and same charges or like charges are there, it will repel each other. Okay. And we have a unit of electric charge. What is the SI unit? Like how we have SI unit for length as meter, how we have SI unit for mass as kilogram, SI unit of time is second. Similarly, SI unit of electric charge is coulomb. You have to write this spelling very clearly, children. Coulomb, C-O-U-L-O-M-B, coulomb. Okay, right. All matter contains positively charged particles called protons and negatively charged particles called electrons. All the matter. So every material or every body has got some charges in it. Especially you call a positively charged particle. Positively charged particle. Okay, positively charged particle and let me write particle and negatively charged particle. Now positively charged particle are called as protons and negatively charged particle are called as electrons. Okay, and I told you the unit of charge is coulomb. The SI unit of charge is coulomb. Now what is 1 coulomb? Okay, now how many charges are there? Okay, 1 coulomb is the quantity of electric charge which exerts a force of 9 into 10 power 9 Newton on an equal charge placed at a distance of 1 meter from it. Now let me explain this to you with an example. Now let us consider a charge here which is plus Q, and here you consider similar charge plus Q, and they are separated by a distance 1 meter away. Okay, now this charge will exert a force on this charge. Similarly, this charge will exert a force in this charge. Okay, now the force of here they are similar charges, so they will exert a force. Now what is the value of force? The value of force is 9 into 10 power 9. Usually the unit of force is Newton, right? We express unit of force in Newton. So the force exerted by these charges will be 9 into 10 power 9. When this will be 9 into 10 power 9? When it is placed at a distance of 1 meter from it, the amount of charge is 1 coulomb. Okay, so 1 coulomb is that quantity of electric charge which exerts. Now the quantity of electric, now here it is 1 coulomb, now here it is 1 coulomb. Now they will exert a force whose value is 9 into 10 power 9 Newton. Now when it is separated by a distance of 1 meter. Just a definition, I mean just you know this, you will be learning in detail about this using Coulomb's law in your higher classes. Now you will be able to understand this very clearly when you go to your higher classes, right? At present, you just know what is 1 coulomb. 1 coulomb is the quantity of electric charge which will exert a force of 9 into 10 power 9 Newton on an equal charge. Now here the value of charge is 1 coulomb. Here also the value of charge is 1 coulomb. They are separated by a distance of 1 meter. The force experienced by these charges is nothing but, you call it, I mean the value will be 9 into 10 power 9 Newton. Okay, and as I told you, positive charges are called proton, negative charge is called an electron. Now what is the magnitude? That positive charges, what is the value of a proton? Charge of a proton is 1.6 into 10 power minus 19 coulomb. The charge of an electron is again 1.6 into 10 power minus. Now when you write the magnitude, here it is plus 1.6 because it is said to possess positive charge. Now here it is said to possess a negative charge, so you have a minus, but the magnitude remains the same. Okay, then the unit of electric charge, coulomb, okay, is much bigger than the charge of a proton or an electron. This you will be understanding using a problem, but now you need not bother about that. You just understand that the coulomb is nothing but it is of very high value when compared to the value of the charge of a single proton or an electron. இங்கே பாரு 1.6 into 10 power minus 19. Minus 19 in the sense this value is considered to be very, very small. But coulomb is much more greater than these individual charges of a proton or an electron. Okay, ma? Now, all these things we read, right? Now, all the substances, as I told you earlier, all the matter or all the material are made up of charges. Now, we were learning about the type of charges, positive charge, negative charge, all those things. So, whenever we take materials, in some materials or in some substance, the electric charges can flow very easily, whereas in some substances, you cannot expect electric charges to flow very easily. So, based on the flow of charges in a material, you classify the material as conductors and insulators. Now, the charges where the electric charges can flow easily, you call those material or you call those substances as conductors. Where you will not have electric charges to flow, you call those substances as insulators. Now conductors, the example for conductors are metals. Okay, especially like metals like silver, then copper, aluminium. So all these metals will allow electric charges to flow through it. Hence these metals are very good examples of conductors. Okay, and alloys. Okay, now such as nichrome. Nichrome is, alloys are nothing but combination of metals, right? Now nichrome is a combination of nickel and chromium. Okay, so these type of alloys also allow electric charges to flow through it. They are also called as conductors. And our human body is a very good conductor. Okay, so which allow materials that allow electric charges to flow through it, you call those materials or substances as conductors. Okay, now those substances which do not allow electric charges to flow through it, they are called as insulators. The substances through which electricity cannot flow or electric charges cannot flow, you call those as insulators. Okay, now examples, you have glass, then you have ebonite, then you have paper, then plastic. All these are examples of insulators. Okay, so materials based on as far as we require. Now here this is how you can classify materials as. Okay, now whenever you have presence of free electrons in a substance, it make it a conductor. If free electrons are not existing, or if the electrons are not able to move, then you call that material as insulator. Okay, now with this introduction about electric charges, conductors and insulators, we are moving on to the definition of what is called as electric current. Now whenever in a material we consider the motion of electric charges. Now whenever electric charges move through a conductor in the sense, for example, it may be a copper wire, it may be an aluminium wire. So wherever you have the motion of electric charges, especially electrons. Okay, we were discussing about proton also. Proton is considered to have more mass, so you cannot expect protons to move in a conductor, we expect electrons to move in a conductor. So the movement of electric charges, now electric charges in the sense we talk about the motion of electrons. Okay, electrons in a conductor will constitute what is called as an electric current. Okay, now how water will flow through a channel from a region of high pressure to a region of low pressure. Similarly, electric current also flow from positive terminal of a battery to the negative terminal through a wire. Now look at this diagram. Now here this is a battery. Hope you are all very familiar with this. You have batteries at home, and when you take a battery and see, one end you will have a positive sign, the other end you have a negative sign, which means now this positive is said to have a very high potential. Okay, very high. We are going to learn about what is called as potential. Okay, then this is said to possess low potential. Okay, in that case there will be a potential difference between this, and always the charges will move from, the current will move from a region of high potential to region of low potential, and it will pass through the wire. Okay, so electric current passes from the positive terminal of a battery to the negative terminal through a wire. And what is electric current? Electric current is nothing but the motion of electric charges. Motion of electric charges in the sense it is nothing but the movement of electrons. Look at the direction of electron here, children. You need to understand very clearly how the electrons move and how the current moves. Electrons will, now this is considered to be negative potential, right? Negative potential will be, here you have electrons. Now here you have blue color negative signs, here you have red color positive signs. Now it is due to the movement of electrons from, try to understand the sentence very clearly. It is due to the movement of electrons will move from negative terminal to the positive terminal. Current will flow just opposite to that. You call this direction of current as conventional direction of current. We are going to have that line in your next page of your textbook, by convention or conventional direction of current. Conventional direction of current is from positive terminal to the negative terminal, which is just opposite to the direction of flow of electrons. Electrons move from the negative to the positive side. It is due to the flow of electrons current is existing in a circuit. So we define electric current to be rate of flow of charges. Rate means with respect to time. Okay, so we calculate time. What is the time of flow of charges in a conductor is nothing but you call it as electric current. Now let us consider a net charge. Net is total. Let us consider a charge Q. Now this is to be a conductor AB and you allow electric charge to pass through a conductor. Then what will be the current flow through the conductor, which is given by the formula I is equal to Q by T. Okay, rate means time. So current is calculated as the rate of flow of charges in a conductor whose unit is electric unit, whose SI unit is ampere. Now whenever you write the SI unit, now here if you are going to write the name of the scientist fully, you need to write in small letters, or only the first letter you have to use a capital letter. Okay, so the SI unit of electric current is ampere. Now when the current is said to be 1 ampere, the current is said to be 1 ampere. I already told you what is the SI unit of electric charge. Electric charge is represented as 1 coulomb. Then time is 1 second. So if the charge flowing in a circuit, flowing in a circuit is 1 coulomb and the time is 1 second, then the current is said to be 1 ampere. So 1 ampere equal to 1 coulomb by 1 second. So the current is said to be 1 ampere when I allow 1 coulomb of charge to move in 1 second. So this is about the definition of electric current. Now all these definitions are there in your textbook. Very important 2-mark questions. Okay, now this I already told you. Now direction of conventional current. Initially, suppose if this is going to be a copper wire, now electrons will be randomly arranged here and there. You have the movement of electrons, but when it is connected to a battery, now here you connect it to an external battery. As soon as you connect an external battery to a wire, what happens to the, look at the electrons movement here. All the electrons will move to the positive terminal. They move to a particular direction, right? So all the electrons, since it is negatively charged, all the electrons will move from negative terminal to the positive terminal, and the direction of conventional direction of current is from positive to negative. Look at the direction here. It is very clearly mentioned in this diagram. Direction of conventional current is from positive to negative, whereas the direction of electron flow is from negative to positive, which is just opposite to the direction of conventional current. Is it clear, children? Hope you understand the concept very clearly. We will be continuing with electric circuit in our next class, children. Thank you.